Yes.
Okay. So the process in which more reactive metal oxidizes first in preference of the less reactive one is called sacrificial protection. Okay, any questions about this, about sacrificial protection?
No, ma'am.
Sure.
Yeah.
All right. Now, this is a short heading on recycling of metals. So we have a few advantages and a few disadvantages. So advantages made, the first one is that it reduces land pollution. Second one is that it's economical, meaning it's a really cheap process. Disadvantages made, the first one is that when you recycle metals and you use that same recycled stuff in making other stuff, the impurities still exist in that metal, right? So these impurities are not good, which is why it comes in disadvantages. So it's disadvantages, and the second one is that recycling metals will have some sort of transportation cost, right? So these transportation costs are a lot. So these also come under the heading of disadvantages.
Okay.
Right? So there are two advantages and two disadvantages. Let me know when you're done copying and we'll move on to another topic.
Okay. Okay, ma'am.
Done?
Yeah.
All right. Now this is a short topic, which is alloys. Now, what basically are alloys? Alloys are a mixture of metals. For example, I have a bar of maybe magnesium. Now, a bar of magnesium will only have atoms of magnesium, right?
Yeah.
However, if I have another bar that has a mixture of magnesium, iron, and aluminum, right? So there will be different sizes of
Right.
atoms in this metal bar. So this will be magnesium, this might be iron, there might be smaller atom for aluminum, and so on. Right, so we have different sizes of atoms in an alloy. Alloy is basically a mixture of metals.
Okay.
Now this we know is pure because this only has magnesium, and the properties of all metals will apply to your pure metal rod. ठीक है? So this is your pure metal. This, however, is your alloy. Right?
Yes.
Now we know that a metal bar is hard to break, right? However, in the case of alloys, we have different sizes of atoms, meaning we have different atomic radii, right? It has a smaller atomic radii. This has a much greater atomic radii. This has an atomic radii that comes in between of each of these, right?
Right.
So we have different atomic radii in alloys. And these atomic radii help us to easily break our alloy. Matlab, it's easier to break than a normal piece of iron, right? So the layers can easily slide over each other.
Yeah, right.
Now we'll write some notes on alloys. Alloys are a mixture of metals, pure metals, consist of layers and by applying force. Okay, so basically, why are alloys even made? Like you could just have a pure metal, right? Why are they made is because they reduce costs. Like maybe your magnesium metal is very expensive, so you mix another kind of metal with it to make a rod of magnesium, which has some impurities, right? But at the end of the day, your costs are reducing, so you use an alloy, right? Another reason for this is that it increases the strength of the metal itself. How? Because you have different sorts of metals and all of these have different strengths, right? Magnesium has different strength, aluminum has a different strength, iron has different strength, right? So all of these three metals combine to give you a strength that is higher than the strength of your individual metal, right?
Right.
So
Yeah.
this is another reason that you use alloys, right? Now there are types of alloys that we will be discussing, but first let's complete the notes and then we'll do that. By applying force, that is why metals are malleable and ductile. What does malleable and ductile mean? Ductile means that the metal can be easily converted into wires. And malleability means that the metal can be easily converted into sheets, right? So we have very
Yeah.
thin sheets of metal that are usually used in window panes, etc. So there's that, and wires, as you know, electric wires, any sort of wires, that's called ductility of a metal. Now, alloys are resistant to corrosion because the number of atoms per unit area decreases. Alloys are harder than parent metals. What do we mean by parent metals? For example, I have a rod of magnesium and my alloy has magnesium and aluminum, right? So my parent metal was magnesium, into which I've added another metal to make it into an alloy. Now, as we discussed, the strength of the individual metal is way lesser than the strength of the alloy, right? Because the alloy contains the strength of all the metals combined. And strength makes the metal harder. So alloys are harder than the parent metals because they do not consist of layers or because they have different atomic radii. Let me know when you're done.
Okay. Okay, miss, I'm done.
Okay, great. Now we move on to types of alloys. Now the first type is called mild steel. This is a mixture of iron and carbon, and it's the only alloy in which two metals are not involved. Why? Because iron here is a metal, carbon is a non-metal, right? So this is this is the only alloy that does not have two metals. Rather, it has a metal and a non-metal, right? So mild steel, only alloy in which metals are not involved. The use for this is car bodies. Now we have another type of alloy that is called stainless steel. This is a mixture of iron, carbon, nickel, and chromium. Okay, so you don't need to remember this part. ठीक है वैसे तो they don't even ask you for the types of alloys, but it's part of the syllabus, so obviously we need to do it. So basically you need to remember the names, right? And also the uses. So stainless steel is a mixture of iron, carbon, nickel, and chromium. This is used for utensils and surgical instruments and watches, etc. Third type of alloy that we have is brass. Brass is a mixture of copper and zinc. And this is used for machine bodies. Fourth type of alloy that we have is called bronze. Bronze is a mixture of copper and strontium. This is used in coins, statues, medals, and yeah, that's it. Then we have another alloy that is duralumin, which is a mixture of aluminum, manganese, magnesium, and copper. Aluminum here is used just for mixing, and the use for this alloy is aircraft making, then we have the last type of alloy. This is a mixture of lead, which is plumbum, and strontium. The use for this is joining electrical circuits. Joining electrical circuits.
Okay, miss.
Right. Now we're done with the topic of alloys, and we will now be starting with the reactivity series. Any questions about all of this?
No, miss.
Okay. Do you want like a 5-minute break if it's getting too much? Because we still have
Oh,
another
no.
hour to go.
Yeah, I know. It's all right.
Okay. Now we'll be doing the reactivity series. Now, in the reactivity series, we'll be discussing reactions of metals with cold water and steam. So cold water in these equations will be denoted by H2O liquid, and steam will be denoted by H2O gas. So let's see what the reactivity series looks like. So this is what the reactivity series looks like. And the first three elements have a violent reaction with water. Magnesium, however, has a slow reaction with cold water. And metals from magnesium, from aluminium and below do not react with cold water. So what happens is that going down, reactivity decreases. Okay? So this was about cold water. Now we talk about steam. So what happens in the case of steam is that we have a very violent, okay, wait. So in the case of steam, the first three metals have a very violent or explosive reaction, meaning if you compare the reaction of cold water with these three metals and the reaction of steam with these three metals, steam will tend to react in a much more violent way, which is why we're also referring to it as an explosive reaction, right? So steam will react very violent slash explosive with steam. And it's so explosive that it is considered not safe. In the case of magnesium's reaction with steam, it is a very violent reaction. So magnesium's reaction with cold water compared to magnesium's reaction with steam has a vast difference. How? Because magnesium reacts slowly with cold water. It's a slow reaction. However, when you're reacting magnesium with steam, it's a very violent reaction. Now here, as you start going down from aluminum till copper, here the reaction with steam becomes slower. And the part after this part these metals, the last three metals, basically do not react with steam. So what is the trend that we observe here? We observe that the metals on the top of the reactivity series tend to react in a much more violent or an explosive way rather than the ones at the bottom, right? So these three do not react with cold water as well as steam, right?
Right.
And the ones above, from aluminum till copper, do react with steam, but the reaction is very slow, right? So you need to keep all of this in mind while you are doing these questions, because they are going to ask you for the observation, and you need to write if the reaction is violent, if it's explosive, if it's slow, or in the case if it does not react, you need to mention that as well. So first we'll move on to the reactions with cold water. What happens with cold water is, for example, I have potassium reacting with water. What will be my product? Okay, so here's a key point. Metal plus cold water will give you metal hydroxide and hydrogen. And metal plus steam will give you the corresponding metal oxide and hydrogen. So with cold water, you get metal hydroxide, and with steam, you get metal oxide, right? So here we are reacting it with cold water. So with cold water, what are we going to get? The metal hydroxide. So what will be my product?
Okay. Potassium oxide and hydrogen gas.
Potassium hydroxide, right? Not oxide,
Yeah.
because it's
Okay.
cold water. So this will be potassium hydroxide plus water, plus hydrogen, sorry. Right, so this hydrogen is a gas. This will be aqueous, and this potassium here is a solid. And since it's cold water, we already discussed that when we're reacting something with cold water, we use H2O as a liquid. So this is done. Let's balance it. There is H2. There's another, so this will be half H2. So we have two hydrogens on both sides. Now we have calcium reacting with cold water.
Calcium hydroxide and hydrogen.
Exactly. This will be calcium hydroxide. And how did I make calcium hydroxide? Ca2
You
plus OH minus. I cross multiplied them. So this minus, since it's just a minus, meaning 1, and OH gets the 2, right? So this turns to CaOH twice plus hydrogen. Now we move on to reactions with steam. Steam meaning H2O in gaseous form. I have magnesium. Okay, let's compare magnesium's reaction with cold water and with steam. Let's first do that. This is with cold water, so this will give me reaction with cold water gives me the metal.
Cold water with metal. With metal hydroxide with
Right.
metal hydroxide.
Yeah, it gives you metal hydroxide because it's cold water, right? So when we're reacting it with cold water, you will get magnesium hydroxide and hydrogen gas. Now let's write the equation for magnesium reacting with steam. So this will be magnesium plus H2O This is liquid, meaning cold water. This is gas, meaning steam, right? This reaction will give me, it's going to give me what?
For metal with for metal and steam, or
Yeah, metal and steam.
okay, metal and steam, metal oxide and hydrogen.
Right. So what will I get in the case of magnesium?
Magnesium and steam, magnesium oxide and hydrogen.
Right. This will be MgO plus hydrogen gas. Now, what's the difference between the kind of reaction that actually happens here? So let's go back and check out the reactivity series. So with cold water, magnesium has a slow reaction. However, with steam, magnesium has a very violent reaction, right?
Right.
So our observations will also correspond to our reactivity series. So this will be a very slow reaction. Very slow reaction. Now, since hydrogen is getting formed, we will write bubbles of colorless gas and here you are going, okay, so magnesium oxide is a white solid. Here what you're going to say is that it's a violent reaction. We know this through the reactivity series. And a white solid is formed, which is magnesium oxide, right? So this is how we're going to compare the reaction. We're first going to go to the reactivity series and we're going to check how that metal reacts with cold water and steam.
Okay. Okay.
Are you done copying this?
Yeah.
Okay. Whenever metals react with water, now here water is H2O liquid. They produce corresponding metal hydroxide and hydrogen. Whenever metals react with steam, steam is H2O gas. So whenever metals react with steam, they produce corresponding metal oxide and hydrogen gas. Now we move on to the thermal decomposition of carbonates and nitrates. Are you done copying?
Yes.
Okay. So thermal decomposition of carbonates and nitrates means that if I have a metal carbonate, meaning I, for example, have magnesium carbonate. So this is my carbonate, and I have a nitrate that is, let's take magnesium nitrate. Okay? So the decomposition means this carbonate breaking down into some sort of other stuff. So decomposition basically means breakdown. Okay, so this will break down into other components, and our metal nitrate will also break down into other components. How is that? This will be due to heat. Heat meaning thermal decomposition. So we provide
Right.
heat to our metal carbonate, heat to our metal nitrate, and they will decompose. How? Due to the heat that we will be providing. So what basically is thermal decomposition? First, let's discuss thermal stability.
Okay.
Thermal stability is the ability of a substance to resist heat. So the more thermally stable your substance is, the more heat it can endure until it decomposes. Right?
Yeah.